Hello and welcome to episode 165 of our SAP on Azure video podcast. Today is October 26th, and together with Robert and Goran, we're here to talk about anything related to SAP and Microsoft. Hello, everyone.
Hi.
So SDAF, or the SAP Deployment Automation Framework, started as a nice tool to simplify the deployment of an SAP system in a consistent and repeatable way. In the meantime, SDAF has grown into a huge project, is leveraged by the Azure Center for SAP Solution, and actually also by a lot of customers and partners. A lot of colleagues are actively contributing to the project on GitHub, and I'm happy to have Kimmo and Hemanth with us, two of the main contributors. Before we hand over to them, and they can talk us or show us a little more in detail what SDAF is and what's new with SDAF, let's take a look at the news from this week. And yeah, let's start, Goran, with our HANA Azure Large Instances.
Yeah, so as always, starting from bottom up, very important topic. I'm not sure if I think we didn't mention in the past, SAP HANA Large Instances, the bare metal boxes available in Azure will be retired by the end of June 2025, meaning all the customer has to migrate to virtual machines. So that's a very important news and also important for the planning. I mean, there is let's say how much 1.5 years. There is enough time, but still it is important to migrate. It's doable and actually, there are many benefits on the virtual machines, and from the size, they are extremely huge. The virtual machine, meaning there is no need actually even to have it the bare metal box, but definitely the VMs are much more flexible and offer much more flexibility than the bare metal box. Yeah.
I mean, just to look back, I mean, when we introduced the HANA Large Instances, there was just no way to have these huge virtual machines. Correct. But in the meantime, the virtual machines are as large as the HANA Large Instances. So exactly. That's why there's no need for them anymore.
There is no need. Yeah, exactly. The next one, very interesting, from Dennis Padilla. We were talking about the virtual machine scale set in the past. He was presenting this as an availability option. And in this blog, basically, he's officially talking about how to use VMSS Flex and Azure NetApp Files for typically you would use for the HANA. The long story, make it short, it's basically he's showing the way how you can use, I mean, with the how you can use application volume groups for the HANA. And deploy them using the zonal anchor VM, which is just temporarily there. On one hand, meaning you also don't need in this context any kind of pinning of the NF. On the other hand, the virtual machines, the zonal virtual machine, which are part of the VMSS Flex, also do not need any kind of pinning, you know. So he's just which is a great stuff, especially for me and Hemanth, because we are doing time to time the pinning process, and this is a great news. And customer will have much more flexibility because the meaning expectation here is that inter-zone latency is definitely good enough for the HANA, meaning sub-milliseconds. Yeah, and no pinning, meaning much more troubles in deployment, much more flexibility in resizing or updates or whatever, you know, because VMs could move here and there. Yeah. So he described the process how to do it. And if customer would use the VMSS Flex and the ANF, this is the way how to do it. Officially supported. Yeah. Cool. I think the next one is from the Robert also.
Yeah, okay, this is interesting. I think we have I think it's already known that we have these reserve instances for virtual machines. So if customer decide to run virtual machines 24/7, for example, then they can decide, okay, to somehow commit to 1 year or 3 year. And of course, we have today, till end of this year, that was the plan announced this year, that we will have this option, this exchange policy option, flexible till end of this year. This exchange policy flexibility means that I can, for example, switch reserve instances contract from E series to M series, or have a bigger M series, and so this called flexibility inside the exchange policy. So we previously announced that we will have this support till end of this year. So from 1st January next year, we will not have that anymore. And now we postponed that date to 1st of July. So that means till 1st of July, customer can still use this old exchange policy, which means changing from one virtual machine type to another virtual machine type, or go scale up, scale down. But again, till July 1st. Why we did that? Because now we have a third option already more than 1 year, savings plans. So savings plans is much more flexible than reserve instances. So if customer needs something like dynamic environment, I don't need something 24/7, or I am not sure what I will use in next following months or following years, then savings plan is better fitted than reserve instances. So this is the reason why we are somehow canceling this flexibility in that reserve instances exchange policy, but it's very important that we now extend that till July 1st next year.
Perfect, cool, great. Thanks for these updates. So now that we have the infrastructure covered, let's go up the stack. And the first thing that I quickly want to highlight is a nice video, the ABAP Story. It is in German, but actually it provides a nice look back on how ABAP came to life and why ABAP is so cool. You can see there are some cool screenshots there. It's a 5-minute video. It has some interviews with some very well-known colleagues from SAP. So if you have 5 minutes, just take a quick look. It's really nice to see and to be reminded of the history of ABAP. So it's a nice video. So this is basically talking about the past, and I mean also some things in the present. But if we move up to the very recent present, Mona Lisa Biswal, she was also already. No, we didn't have her on the show, did we? But we had colleagues of her, and we talked about her because she had released a plugin for SAP GUI that uses Azure OpenAI to help you with code completion. So basically a GitHub Copilot for ABAP, and she had shown this us in the SAP GUI, and now it's also here in Eclipse, and she's done a really nice job there. So everything is documented on GitHub, so you can really go into GitHub and download all the required files. And then you have here this generate code plugin in Eclipse. She has some nice videos that show you how to get started and how this looks like. So if you are using Eclipse, if you want to test how Azure OpenAI can help you in developing ABAP, then check out her blog post. It was just released. I think there's already a lot of excitement around this. Everything is in GitHub. So if you can also contribute there. Another thing that just happened yesterday, Charles Lamanna and the it says here Dynamics, but it's also the Power Platform team. They have these, I think, twice a year. They have the business application launch event where they talk about new functionalities and stuff like that. And just yesterday, they talked about the new enhancements in Dynamics. But honestly, for me, it's much more interesting to look at the Power Platform things. And there are, I mean, AI is everywhere. That's one key thing. But the cool thing is it's not only AI. There are a lot of other new functionalities that are introduced in the Power Platform. So Power Apps, Power Automate, Power Virtual Agents, Power BI. We will spend, I think, at some other point, a little more time on this because there are some really, really cool things already announced. And actually, Ignite is coming up, and I've already seen a few other things that will be showcased there. So this will be also really, really fantastic. The last thing that I quickly want to mention, Michael Mergel was on the show before. He talked about his Teams integration and how from Teams you can actually manage certain SAP tasks like unlocking a user or checking a job status and stuff like that. And now he has created here this GitHub repo where he outlines all the steps to get this working. So how can you get started with Power Automate? What are the things that you need to configure to integrate this into Teams? So it's a really nice documentation on how to get SAP management basis tasks potentially in a chatbot in Teams. Good. And with this, we're done with the news from this week, and we can hand over to our main guests. Before we go into the topic, Kimmo Hemanth, can you quickly introduce yourself? What do you do at Microsoft? And yeah, just talk a little about yourself.
Sure. Yeah, so my name is Kimmo Forss. I'm based in Helsinki, Finland. What I do at Microsoft, so currently I'm the development lead for the SAP Deployment Automation Framework. So that means writing code, helping customers, doing documentation, all of the fun stuff.
Cool, thank you.
Hi, I'm Hemanth. I'm part of the Customer Solutions and Incubation team, the QA on the SDAF, and also write code, help customers deploy their landscapes using SDAF. And also have the charter of the innovation and incubation on the Customer Solutions and Incubation team.
Perfect. Good.
And
so
Hemanth, you forget the most important part. You're a colleague of mine, you know.
Yes, yes. that's the most important thing. Yes.
Perfect. So we already had a session about SDAF in the past, but maybe it's good to start with an overview. To just quickly recap and yeah, basically give an introduction on what SDAF actually is.
Yeah, that sounds like a really good plan. And I hope you can see my screen. Yeah. So we have like a quick overview of SDAF for some of our viewers who are tuning in for the first time and or have missed the previous episode where we talked about the SAP Deployment Automation Framework or SDAF. We'll quickly do an overview on architecture and then we'll jump into the demos and talk about the new features and functionalities that have been released over the last few releases since the last time the team was here on this. So just in a nutshell, if you actually look at the slides, the SAP Deployment Automation Framework is an open source orchestration tool used to deploy, install, and configure SAP environments on Azure. It enables the creation of infrastructure for SAP landscapes based on SAP HANA and NetWeaver with NEDB, utilizing Terraform for the infrastructure deployment and Ansible for operating system and application configuration. The framework supports deployment of pretty much any supported SAP operating system versions into any Azure region where the services required for running SAP workloads are available. Some of the benefits, I mean, it's quickly touching upon the benefits of using an automation solution. All of us kind of get it, is that you get with SDAF, you get like reviewable code via ISE and the configuration as control. You have a streamlined deployment process and flexible SAP architecture deployment. We'll talk a bit more about how the architecture looks in the coming slides. But before that, quickly want to talk about the ACSS, the Azure Center for SAP Solutions, which uses SDAF for the install experience, the create experience, and it actually is the umbrella for bringing in a visibility of your SAP workload on Azure into one pane of glass view that you can create for yourself, which is available in the form of various tools and frameworks, which are bundled along with the core product and services that are there. Now switching back to the open source side of the world, if you look at SDAF, there are two main components in that, right? One is deployment infrastructure and the SAP infrastructure as spoke components. So the deployment, like I said before, utilizes Terraform templates to create an infrastructure as a service based deployments to host your SAP application. So you're creating the infrastructure that is required for running your SAP application on Azure. Now, the two core components in this is the control plane, which is the core, as you, maybe it's easier if I use the pointer. The control plane, right, which is, it's used to deploy both the SAP infrastructure and configure the SAP application on the deployed infrastructure. The Terraform templates are used to create the infrastructure, like I said, and the orchestration engine that sits in here, which is primarily based on Ansible, then configures your application. The second part of it, also the control plane houses the deployment infrastructure from which other environments are deployed, like your workload zones, right? And it provides various services like your deployment agents for running your Terraform deployments and Ansible configuration, persistent storage for your Terraform state files, which are required for you to actually come back and review if there is a drift in the infrastructure, and a persistent store for your SAP software that you download, and an Azure Key Vault to securely store your deployment credentials and the configurations for your web application. Now, the process involves the use of the control plane VM to run orchestration scripts, including deploying the Azure resources via Terraform. They also serve as the Ansible controller. So you can have like more than one control plane VM or more than one deployer that is actually configuring your or managing your infrastructure. The second part of it is the workload zone. And one of the key things about the workload zone is, while we talk here about partitioning the workloads, an easy way to understand what a workload zone is kind of thinking it like acting as a swim lane for your workloads, right? Creating a demarcation between each of your environments where you have your dev, test, QA, and prod. All of these can go to different workload zones, thereby achieving the segregation of network traffic or isolation for your deployments that is needed by your policies. And it does contain shared Azure infrastructure, which is required for the SAP deployments. And the final part in this is the SAP systems themselves, which we track using the SID. So let's say you're deploying a SID called R86, you would have application servers, SES VMs, your web dispatchers, and database servers that are there. And that actually describes the deployment from an infrastructure perspective. The control plane also has also acts as the Ansible controller. So it actually runs the playbooks that are required to configure your SAP system. So in a nutshell, it's a packaged way of deploying and configuring your SAP workloads to run on Azure. We do try to bring in the latest developments and enhancements that come in and that are released as part of a documentation into the framework as early as possible. And we do have some of those, like Kimmo is going to talk about during the demo, and what are the new features that we have in SDAF. But essentially, to sum it up, it's an open source package solution which you can use to deploy and configure your SAP applications on Azure.
And I think what you just said, it is open source. So all the code is on GitHub. So if I'm a partner, if I'm a customer, I can take it. First of all, I can exactly see what is happening. So if I want, I can really take a look at how you do it, what's being deployed, and so on. But then I can also just take it if I'm saying this is great, but I want to do X, Y, Z on top, or I want to change some things, then I can just fork the repo, and then I can do my own things and adjust it as I like.
Yes. One of the things that helps us with some of the customers who really want that kind of customization is that they usually fork the repo to their own internal projects and customize it to their own needs. We have a few customers in Australia who built their own bombs to deploy. We will talk about bombs in the later slides, which is essentially an application manifest, right? So they've built their own custom bombs to extend the solution to deploy other SAP products, right? Which they needed they needed to deploy on their landscape. And there are customers who do things like, hey, we don't want to go with the standard deployment process. Like, we don't want a deployer to be a VM, but we rather want it to be running in a container.
Oh, okay.
The solution is extensible. We'll talk, like, that's a good segue into the next slide, where we started off with the foundational building blocks, where you had this Terraform, Ansible, and custom images, etc., that are available as discrete building blocks. So the framework itself is modular in that each part or each component can be extended individually. You don't have to, let's say, deploy your infrastructure using the framework. We do have a lot of customers who bring in the infrastructure and then configure it using SDAF, right? ACSS is a good example. They don't use Terraform, to my knowledge, to deploy the infrastructure. However, they configure that infrastructure using Ansible. It's similar to what some of our customers do. If they're more familiar with a different infrastructure deployment technology, or a different IAC tool that they want to use, they can bring that in. The
Nice.
orchestration layer that we have right now is Azure DevOps. We do have customers who don't use Azure DevOps. They orchestrate it using different tooling. It supports that as well. So the evolution of SDAF actually shows that we have achieved a level of execution maturity where the user experience, so to a point where we can focus on the user experience, rather than worrying about if the orchestration layer or the foundational building blocks are set properly. It's kind of like what Will says, right? Like, protect the trunk and then the leaves grow themselves. It's kind of like you branch out into different use cases and different scenarios if the foundation is solid. That's what we have with SDAF, is that the foundational building blocks we have are solid. We do keep improving them, adding new functionality, finding bugs and trying to fix them and all of that, which is BAU, business as usual. But at this point, we are at a level where we can focus on improving the user experience by providing them more and more ways to easily configure and deploy the infrastructure.
And Hemant, as far as I know, as you mentioned, okay, it's a different operating system, different databases, different SAP versions, and different SAP deployments model, meaning from central system on one VM distributed up to high availability across the zones, meaning those stuff could be used from dev tests, which generally do not require the HA from a customer side, up to the prod system, which do require an HA typically, right?
Yes.
Correct. Yeah, and one thing that I wanted to add in the open sourceness is that we also have customers who've taken the code base and extended that and then provide pull requests to actually give that IP back to us, which is actually how open source should work, because that actually, it's great for us because we get new capabilities. It's also great for the customer because they don't have their TCO for their solution goes down because they build it, but then they hand it over for us for maintenance. So it's actually working really well in that sense as well.
Yeah, actually, when I checked the GitHub repo yesterday, I remember the first time we talked, I think, Kimmo, you were basically the only contributor. Maybe there were two others or something like that, but you were the main one. And now I saw that there are like 20 people, more than 20 people that have already contributed. Yeah. And so it's clear that there's a lot of momentum also from others with this.
Yeah, and you mentioned extensibility. So one of our goals is to try to build hooks into the orchestration so that if you have a business case, let's say that you have you need to install an antivirus agent. Like, we wouldn't in SDAF have the ability to deploy all of them because there's so many. Mm-hmm. But what we're actually providing are hooks into the orchestration where we can essentially have pre or post tasks. Great, so we could the customer could have some specific steps that they want to do after, like, the database is installed. They could run their own, we could have our orchestration actually run their Ansible playbook, which would configure Azure backup for them, as an example.
Nice.
So with that extensibility, we would like to minimize the number of times where the customers have to clone it and make changes in our code. We would like to have those entry and exit points that we can extend so that we become a kind of plug and play type of orchestration flow.
It's truly kind of like providing a framework that is modular enough that it can be extended without touching the foundational building blocks.
Yeah, so coming back to the UX, so we have the demo. So one thing that we realized, so can I take over the screen and start doing some demos?
Sure, Kimmo.
So one of the things that we realized as the next step was that, so when we look at the way that we actually do our configurations, so since it's Terraform, it's actually driven by what we call parameter files. So essentially, like if I look at a SID, let's say look at this SID R92, so it has a parameter file that describes the parameters that we use for the system. So what we've done is we've made these quite verbose. So we actually have inline documentation for the parameter files so that you actually know what each parameter does. So it makes it easier for people to understand how to configure it. However, what we also realized that creating these parameter files manually is a potential, like there's a risk that you just do typos, etc., because it's a manual activity. So in order to address that, we've actually created a application service that can run in the customer subscription, which is essentially a configuration front end on top of the SAP artifact. So this application, with this, you can configure the workload zones that Hemanth mentioned. So if I look at, for instance, a workload zone, at minimum, what you require when you deploy a workload zone, you need to tell which environment it belongs to, because this environment is then used by the automation to pick up the correct deployment credential. So we do recommend that you use different deployment credentials for your different systems, because that way we can minimize the blast radius. So if your dev SPN would be hacked, it would have no access to QA, production, etc. So you specify the name of the environment, the location, and you give a logical name to the VNet. We use this logical name in the naming of the resource, and then you would provide your address spaces. So this is kind of the minimum to deploy workload zone. So network logical name and the address spaces, and then we also would specify like what is the shared storage solution that you have. So we support natively AFS and ANF. So we actually support ANF with the AVGs. So to the document that you mentioned that Dennis wrote, we actually can deploy that using SDAF. And then, so this would be kind of the minimum set of parameters. However, if you want to have more control, you just toggle the advanced switch, and then you get additional parameters that you can start to fill in. So do you want to use private endpoint? So by default, we deploy the system secure. So all storage accounts, all key vaults are protected by private endpoints, which means that there's no access to those entry points outside of the VNet or outside of the paired VNets. So you get a higher level of control. If you want to go all in, you click the expert tab, and then you can actually choose to say, then you get the full configurability. And one of the nice things here is that we are integrating with the customer's environment. So we support both greenfield and brownfield deployments. So if I want to configure a workload zone that uses an already deployed network, I could just go in the editor and say, actually, I want to deploy into one of, so these would be the networks which are part of that subscription. So I could just say, okay, I deploy into the dev VNet, and then I can just pick up the ARM IDs for the resources. So then I don't need to worry about the subnet address prefix, etc. So this makes it much easier to perform the configuration. And then once you've done with it and save it, we save this object in a table storage in one of the storage accounts in the control plane. But then when you do the deployment, what we actually do is we persist this configuration as a Terraform variable file in Azure DevOps, and then we trigger automatically a pipeline. So it becomes really easy, and then this in a way acts as a CMDB for all of the SAP workload zones that you have, and the same thing goes then for like the systems. So we have the ability. Let's say that if we want to configure a new SID, so let's take this guy as we can take an existing configuration. So let's take the X04. So the way that we name our artifacts, so as I mentioned, we have the environment, we have the region, and then we have the logical VNet. So we get unique naming for resources, and that's important because these names will actually be then the names of the Terraform state files, which need to be unique in SDAF. So coming to capabilities, so let me just toggle on all of these so that we can see all of the capabilities. So we target a particular workload zone. We support doing deployments with either a single IP per NIC or dual IPs. With dual IPs, we can actually then define the SAP virtual hostnet support. So we actually have 2 IPs per NIC, so we can then install SAP on the secondary IP, which gives us the ability to manage the systems with things like Llama. We also have the ability to just say that if I have this checkbox, it'll deploy using VMSS Flex. Same thing for the Premium V2, so we have full support of those. We have then some additional capabilities that actually are more intended to instruct Ansible what to do. So for instance, this checkbox here, if we check this, then we will create a parameter for Ansible that will automatically, once it's installed all the operating system packages, it'll then automatically update them to the latest versions, again, driving operational excellency. So for fencing, we can say that, hey, do I want to use MSIs or do I want to use SPNs? Everything is configurable. We added the support for simple mount in the last release. So with this, we can actually, on SUSE environments, simplify the pacemaker configuration even more. So as you see, the list is quite verbose. So we have the full ability to actually configure quite a lot. So let me just untoggle these so that we have a little less clutter on the screen state. So then what do we support? Like Hemanth mentioned, we support HANA, and then we support on any DB with NetWeaver, we support the other kind of these other databases that we support. From a distro point of view, so we have a default list of what we support. However, this list is configurable by the customer. So if we have a customer who's a Red Hat shop, they can just provide their own override for this field, and then they would be able to list the images that they support. And we do support custom images as well, so the customer could just provide the resource ID for an Azure custom image, and we would deploy using that. Zonality, we can deploy cross zones just by having the zones like this, or we can deploy into single zone, etc. And then, so in this case, let's do now Z. Let's do SO6, and then just click save. Then what happens is that we actually now have a new object here. This is not yet deployed. If I click deploy, the system will just prompt me, but this is the system that will be deployed. If everything looks okay, then I just say yes, deploy. And what will happen is that this will take this configuration and in Azure, and then copy that file into Azure DevOps and trigger a pipeline from there. So if I go to Azure DevOps, so this is how the kind of from a DevOps point of view, we have the pipelines and we have the configuration files. So if I would go into DevOps, go into repositories, We have a hierarchy for like the different artifacts for the deployer, for the workload zone, for the library in the system. If I go to the system folder and just click on which was last changed, so we can see that this folder was just added recently. And if I go into that folder, I see a Terraform variables file that describes the thing that we just configured. And then if I would go into pipelines, what I would see is that we just triggered off a deployment for that x06 SID. And in DevOps, I could go in and check if I wanted to. The benefit of DevOps is twofold for us. It gives us the execution engine. It also gives like ability, we get all of the logs automatically stored, and then we get version control for our configuration files as well. So that is kind of how the infrastructure gets deployed. So whilst this is running, I mentioned that we do support, we have full support for DNS. So if I go and look at what that DNS support actually gives us is, I don't like the Teams bar, it hides the thing. So what we have is the ability to either deploy a DNS infrastructure as part of the control plane, or we can use an existing one. So this is our DNS that we're using for the test environments. So here we have a private DNS zone for the VMs. We also have private DNS zones for all of the pertinent resources. So for all the file shares, all the storage accounts, all the key vaults. So if I look at, for instance, the private DNS zone for key vaults, so these are all of the SDAF based key vaults. So for the different workload zones, so just for the test one, for the QA one, etc. And the fact that they are registered in private DNS allows us to actually protect them better. So because if I then look at so this is a system that I already deployed. So if I look at the resources, for instance, you can see that we have private endpoints. So if I go and check the deployed private endpoint, you will be able to see that that private endpoint is registered to DNS. So that means that in order to access the SAP mount, I cannot access it from outside of the VNet. I have to come at it via the private endpoint. So that means that like we're as secure as we can by default when we do the deployments.
That's really, really cool. When I mean, this has now really grown to an expert tool, I would say. So is now Azure DevOps a hard requirement for this, for example? Because I still remember when I just opened my Azure CLI and then I just executed or I just ran Terraform and then it worked, or
it's not a hard requirement. So you can still do, if you want to deploy it kind of the old school way, is we have essentially two parts. So like, and in the documentation we have tutorials for both. Mm-hmm. So you can use DevOps to do it, which actually gives you the web app and other. But if you want to use a kind of more traditional approach, you can still deploy the environments using our shell script. So we have a tutorial and we can provide the links to all this where if you follow through this, you can actually get everything deployed automatically for you. And then you can configure it. And what we do, one of the challenges that we're trying to overcome with Azure DevOps is that if you're doing your deployments from just a virtual machine in Azure, what happens, and if you have all of your configuration files on that VM, what happens if that VM goes down? Mm-hmm. Then you would lose your configuration files. So one of the things that we added in the release that we are releasing this week is the ability that for those scenarios, actually take those TFVARs file and copy them into a storage account so that we actually keep a copy of them available as well. So we're like a lot of the things that we've done in the latest releases have been focusing on operational excellence and making sure that we're building in operational capabilities like DR, etc., into the framework so that it's more resilient.
Really nice.
Well, yeah, Kim, maybe to both of you, I mean, this is a lot of work and this is a lot of things that you can do, installations, end-to-end complex stuff. And of course, it does help. However, because there is a lot of stuff, and this is an open source as well, people are contributing, how you are handling support, how that support works in a open source world here, you know. I mean, I imagine when everything is pink and green and works, all is good, but
So the way that actually the thing that gets the code that you find in the public repo is actually being validated and tested by a joint venture that we have with the ACSS team. So we do a lot of the development work in an internal repo, which we actually, before we release it to the public repo, we have a bunch of quality gates that we go through. So for instance, any changes into the Ansible will be validated by the ACSS team. They will run tests in the Canary environment to deploy like HANA using all of the supported configurations that they have. We will do, before we do releases, we will make sure that we validate that we can do the full installation. So like the NetWeaver, NEDB configurations that we have. So with that, we're fairly confident that when we release things that there shouldn't be any major issues. Of course, because we have so many permutations now with ANF, with AFS, with Premium Storage V2, with VMS Flex, of course things could happen. So we do have then GitHub issues is the preferred way for customers to raise issues, and then we will try to address them as quickly as we can.
Nice.
So I think since we still have like 50 minutes, Hemanth, do you want to talk through the actual SAP and the installation part and the configuration as code part?
Sure. Let me share my screen again. So you should be. You can see my screen.
Yes.
So this is a different deployment than the one Kimmo kicked off. I had run through a pipeline. So I did my configuration manually. So just to show that you don't have to rely on the web app. You can take the TFVARs, the examples that we have on the GitHub repo in the samples repo, and you can tweak it to match your requirements, right? In my scenario, I'm actually deploying a RHEL 8.4 HA deployment where I have some tweaked some parts of it, right? Like this is still the old way of doing things. The newer way is what Kimmo demoed. It's the preferred way of creating it, because if you need to create these the configuration files en masse, that would be the way to go, because you would take a configuration, make it a template, and use that template to create more and more SID configurations that you need. As long as, like, let's say you have you want to deploy 50 or 60 RHEL-based machines, you can create one template for that and use that template to create the configuration files for the SIDs that you need. The major thing that you would change in there is probably the instance numbers here and the SID name, and that's about it. You save it, like Kimmo showed, like x06. You can have multiple different SIDs just being created, and when you hit deploy, that configuration comes and gets stored in DevOps, and also to the storage account, right? So this config file was what I ran, and what happens when you actually run through this or run the pipeline for doing the yeah, that's okay. When you actually go through deployment, what happens is it actually goes through the Terraform, actually creates the various components that are needed. As you can see, this deployment was done about an hour and a half ago, roughly. Before we started, as I just kicked it off, it takes about 10 minutes to deploy, about 8 minutes it shows here, but we have a bunch of things that get checked before we actually do the deployment. Now, if you look at how the deployment looks. It has the proximity placement groups just for the application tier. The databases don't get deployed into it because we are in a region where you don't have to put the databases in a proximity placement group. So we have this. This is an ANF-based deployment. So you have the ANF volumes that get created. It's a custom configuration where I have specified different max throughputs than what is recommended by SAP. However, since it's being tested, it actually gets deployed in the workload zone. Like I said, like you can actually segregate your workloads based on which environment they cater to. For me, this is my dev environment. So I have these created in the dev workload zone. Some of these are shared volumes, so they get deployed here. It's a highly available deployment. Hence, you see like HANA Data 1, HANA Data 2, one for the primary node and the other for the secondary node. And like Kimmo was mentioning, you do get the private DNS zone records created here. And also, if you just go to the sap.contoso.net, this actually serves as, when I run my configurations, it actually creates records for the load balancers as well. So there, the pipelines, we have different pipelines, right? You have one for deploying your control plane, then you have one for your workload zone deployment, then you have something for the software acquisition, which we'll talk about in a little bit. And then you have the SID infrastructure deployment. You can even remove deployments that you have done once you're done with the if you're doing a dev or a test landscape, if you need to refresh or if you need to recreate the environment, you can remove them from here as well. And then the final one is the configuration and the SAP installation pipeline. I have done this as on Tuesday. It takes about 3 hours to fully configure, patch, with the OS configuration. So we have it in different stages. One, you have the base OS configuration, where you're configuring the repos, patching the system to apply the latest security fixes, etc. Then you have the SAP specific operating system configuration, where you're adding the user accounts, doing the mounts, exports, and stuff like that. And then you go for the central services, the database installations, high availability configurations, the primary application server installation, the additional application server installations, and if you so choose, like web dispatcher installations as well. And finally, you have a step where it actually allows you to register your system to the ACSS as well. So because I'm using the same SID and trying to deploy the same BOM, all I need to do is come here, click Run New. It has all these options populated for me. I can say register your system with ACSS. It's a non-prod S/4HANA system, and just click Run. And it actually starts off configuring my deployment. And this is going to run for 2.5 to 3 hours, depending on how your infrastructure and the configurations that you have chosen. So it keeps running in the background. Obviously, we're not going to spend a lot of time on the screen. But
the next 3 hours we can watch cat videos and wait until it finishes.
Yeah. Just being conscious of time, what we can do is actually quickly take a look at the resources that are available from an SDAF perspective. The technical documentation is available on the Microsoft documentation site for SDAF. The short URL would be aka.ms/SDAF. And the GitHub repository is available under GitHub Azure SAP-automation. This is the main repo where we work. Or make releases on this repo. So if you go to the SAP automation/releases, you have all our latest release information available there. The one thing that we have talked about a little bit, but we haven't actually touched upon in the conversation, was the BOM, right? A bill of materials is essentially how does SDAF actually configure the SAP application on your machines? So what we do is we rely on something called as a BOM. It's essentially it's an application manifest, right? That is used to configure the application. So it's a structured organization of all the materials that are required to run an SAP installation on your machine. Now, while the process is automate, you have a pipeline that helps you to download these components for you. You would need to provide your own username and password, and you should have the authorization to download the relevant components from SAP. That's the important piece. But for you to create the BOM, it's kind of like you go to the maintenance planner, right, and create a new system, and then see that, hey, these are the components that I need to deploy if I need to configure a NetWeaver or an S4 HANA system, and you essentially roll it into a YAML file. So you need to locate and download the relevant SAP installation media. And this is crucial as it gathers all these necessary files required for the SAP installation and allows the framework to actually do the installation on your behalf. Right. You could roll your own BOM, which some of our customers have done for components that we don't have the samples available with us. What they do is one thing that they need to do when they actually are creating a custom bill of materials is they need to create the INI files that are required by SAP ends to actually run the installation for you. So there are two essential steps, like one, the acquisition of the media that is needed for you to install the SAP system. The second is the INI files that are required for the configuration. And we do try to make it simple by allowing the customer to actually download these, right? And the download software phase essentially reads the samples that we have and downloads them. If you need to extend that, like I said, the framework is modular enough that it can be extended to install other SAP applications as well. So it allows you to actually download these, but you have to use your own S-user password, and you need to have authorization on the portal to download this.
And one of the benefits with this approach is that we get repeatability. So we can actually ensure that, like if we do the dev installation with this version of SWPM, we do the QA installation with the exact same version, etc. So that gives us the repeatability, which is really important for testing point of view.
Yeah. Because as you said, I mean, I only download the software once, or I mean, once for a whole environment, basically. Yep. So this is not necessarily for each and every installation.
Once, and that's why, and it gets persisted in the control plane, and that's where we get the repeatability. So it's I would say that the most complex thing at this time for extending this is actually the custom bill of material creation, because like there's no easy way to decipher some of those components, like the application identifiers. So like what's the product ID, etc. So those things you have to kind of do a bit of investigation. So one way is to just run the installation once and finishing it before it actually installs, and then you would take the ini file.params and you will get the identifiers from there. So it's the most kind of cumbersome thing, but it's a learning curve that you only have to go through once. So once you know to make one BOM, you can make any BOM. So the process is the same.
And you have a lot of examples there on GitHub as well.
Correct. Yes.
Yeah. Very nice. So maybe one last question. So for a simple system, how long does it take from the very start to the very end until I can open up the SAP GUI and connect to the system?
1.5 hours. If we have the software downloaded, then like 10 minutes for the infrastructure, and then like 1.5 hour if it's a non-HA.
Of course.
So then I would say like 1.5 hours.
Really nice.
We try to stay within reasonable timelines.
Yes.
For standard installations.
I mean, 1.5 or 3 hours is still great.
The main challenge is like SAP is not really a very automation friendly product in that sense that like you have to wait if you have to kind of when you're setting up your high availability, like how to validate that all of the services up and running, etc. Like there's no good APIs. You have to you can't use the traditional ways. You actually have to understand a bit of the underlying foundation, how SAP works, and that's why I'm so happy to work with you guys who know that. So.
Cool, perfect. Well, Kimmo, Hemanth, thank you so much for this great overview, this update. I think there's some really cool new functionalities. I very much like this configuration editor. I think that makes it really much easier than scrolling through all these Terraform files. So I think that's really fantastic. So thank you very much. I hope a lot of our listeners, viewers, take a look at this and test it and provide feedback, and then maybe in another few months we can have another update from you with additional new cool functionalities.
Yes,
definitely. Yes.
Perfect.
Sure.
Thank you so much.
Thanks
Talk to you soon. Thank you.
Bye.
Bye-bye.
Bye.